Hi, my name is Michael Grenier and I'm a technical sales specialist for Autodesk working out of the Montreal office, and I'll be presenting this webinar today. This webinar is going to be splitted in two different examples, where the first one will be covering reading of a text file that we will use as a batch file to be able to program several parts in one single click. And then, in the last section of this webinar, we'll be taking a quick overview at how we can hook up Visual Studio to PowerMill for people that are looking into creating a bit more fancy user interface. But for now, let's start with PowerMill at creating our macro to read in a batch file. The first step is to look at what the batch file looks like. So I do have already created that text file in here that I'm going to open to give you an idea what it looks like. So it's only a matter of adding a couple of file addresses into that text file. Those file addresses could be created by an internal ERP every day, so that once we get to the job every morning, we will only need to run this macro and PowerMill will program everything which is into this file. To start that macro, we will use our function template that we've previously created in the first session. Let me open this template just here. As we can see, it's a pretty simple template. All it has is my main function with the selected toolpath that we were using before. But now, because we will be applying that macro on several different files, it's not gonna need any toolpath anymore. So I'll get rid of this guy and start writing my code within the two curly brackets. We'll see in a couple of minutes the reason why I'm creating it as a function. But for now, let's just write the code to be able to read in the text file. The structure is not really complicated. All we need to do is to first of all create a string variable that is going to be able to hold a list of values. Up to this point, pretty much every values that we've been created were either simple string or sometime array. But now with the list, we will be able to save everything that we have in our text file on different lines of this list. So let's define that string list variable that I'll call files, and I'll make it equal to nothing because it's the file read function that will populate that variable. Now we can start by opening the text file, which we will need to do by using the file open command. So I'll write file open, then I'll have to write down my file address and say for read as batch file. So batch file is going to be the name of that currently open file. And then I'll say file read, and I'll store everything that is inside of this text file into my files variable that I've just created. And I'll say from batch file because I want it to read what I've saved into my batch file variable. And then I'll close this file. Like so. That is pretty much the structure we need to use every time you would like to open or read a text file. Now all I'll need to add is the link to my file, which I'll copy like so. Now that the file has been opened and saved into a variable, I'll be able to use pretty much the same strategy that we've used before. So creating a for each loop that will allow us to loop through every single line that was saved in this string list variable that we've created previously. So I'll say for each file in $files, open the curly brackets, and then just for testing purpose, I'll print all of the values within the echo command window just to make sure that we can double check what we've just done. So I'll print the currently read line into the command window. Let me save this file, and then I'll run that macro that we've just created, but let me show my echo command before so that we can see everything being printed out. So let me run that macro that we've just created. As we can see, it did not do much, but all we can see is that those two file names that were saved into my text file are now printed out into my echo command window. That means that I will now be able to import those files into PowerMill without any user interaction. Let's go back to our macro. Now, it's going to be time to apply some actions to our macro, because right now it's only printing files, which means I can get rid of that. And instead of adding all of my previously created macro within the for each loop, I'll create a second function. It's not mandatory to create that second function. It just makes the code much more easier to read in. So I'll create that function, whatever the name. I can say auto programming, and then I'll open the parenthesis because I will need to pass the file name each time we run that function. So I'll create a string that I'll call $file name, and then open my curly bracket as usual. Now let me run the original macro to show you what it does. I'll run it by clicking that button, just so you can see that it's currently importing a model, and then it's doing everything as we did on the first session. So it's creating the old feature sets, it's applying all of our drilling methods to this feature set, and it will also generate the NC program. Almost there. The program has been generated. Now let's take a look at this macro. It will be this guy. I'll just copy and paste everything into my function. And then we will, of course, have a bit of modification to do, because we will not want to close the dialogues every time we run a new part. So we may want to do it at the very beginning of our loop and do the same at the end, put them back on once everything is completed, not after each file. And of course, our message info box that will appear, we don't want it to appear for every file. We want it to appear once the batch file has been fully readed and applied to those models. That should work. Now we will also need to change the import model section, because we are only importing that specific file, which is not what we want to do. What we will want is to import the file that we are passing to our function, which means that I can replace all of that section with my current file name. And then, of course, at the end, before we finish, we may want to close the project and save it. So I'll add the project save command and the project reset command. All that makes quite a lot of sense, except that we need to think that this project has not been saved yet. I'm using the project save command, but it has never been saved to a specific folder. What we could do is to try to use pretty much the same folder as where the solid model comes from, so the address that we find in our batch file, But to do so, we will need to modify the name a bit. Let me show you why. If I was to go back here, when we save a project in PowerMill, we need to save it with a name and a folder. We cannot have an extension to this name, which means that we will need to modify what is read from the text file. Because all I want to keep to save my project is that section of my name. Now, to do this, we will need to create a new string variable that will hold only a part of the original file name. Let's do this. I'll create a new string that I'll name project path, and that will be equal to only a part of my file name. To get only a part of an existing string, what we can use is the substring function. The substring function requires three different parameters, where the first one is the original string, which is our file name. The second one is the index where you want to start grabbing some stuff out of it. Let's say that this here was my address. 0 will be C, 1 will be the semicolon, and 2 will be the backslash. I want to grab from the very first letter, so I'll say 0. And then the last parameter is going to be the length that we want to grab. Again, we don't really know the exact length because it's going to change depending on where the file is saved and also depending on the name of that file, which means that I'll need to compute the name of that current string. And to do this, we will need to use the length function. I'll say length $file name, close parenthesis, -4, because what I want is the total length of my address minus 4 letters, which means that I start to 0, I go up to the end and back up of 4 letters, and this is what it should give me in that variable. Now I can use this guy to save my project as, so I'll say project save as project path, and that should do it. Let's save that macro and close that, and then we can run it one more time. Here we go. Now it's giving me an error. Let's see why. Simply because I forgot to call my function. It's not because the function is part of our file, of our macro, that it's going to call it automatically. Of course, I'll need to call my auto programming function and transfer the file name to my function like so. Now I'm calling that function, and what I'm going to pass to this function, so the value I'm going to pass to it is going to be the current file that is analyzed. Let's try again. Now we can see that the first model is imported and being programmed. And in a few seconds, we should start seeing the second part being imported and programmed automatically. Perfect. Second part is imported and being programmed. Again, like I said at the beginning, that will be a really good example for companies that will have an ERP where the production manager will be able to automatically create this text file every day and pass on to the programmers so that every morning, all they have to do is to click one single button and PowerMill will open that automatically created text file and program all of the parts associated with it. Now, if I was to get back where the model were taken from, I could see that I have my two ejector plate that were programmed, and within those I also have my NC code that were automatically generated. I could, of course, reopen those projects if I wanted to make some modifications or make sure everything was done is perfect, but at least every toolpath have been computed and applied to the plate. That is pretty much what I wanted to show you in that last PowerMill macro example. So now let's jump to Visual Studio to see how we could hook up one of our projects to PowerMill. Let me just open another project in here. Perfect. Now while it's opening, let's jump to Visual Studio. There are a couple of versions of Visual Studio available on the market, but there is one which is free that is called Community. So if you are a new user and doing stuff for yourself, I would recommend you use Community, which is free. Community will include quite a lot of functions, and you can do really advanced stuff in that free version of the software. If you want to create a new application, all you need to it is create a new project. Then Visual Studio will ask you what type of project you want to do. Visual Studio has changed quite a lot over the years, where in the past we will get different software for Visual Basic, C# or C++ programming, where now we have everything within the same Visual Studio interface, which means that you could decide to program in C# or Visual Basic within Community. I'll use Visual Basic for this example today. And then within Visual Basic, we have different type of project you can create. We won't go through everything today, but just know that most of the time people will either use the Windows Form application or the WPF application. WPF is what is kind of suggested right now. It's the new way of doing the forms. So I'll go there and use this type. Our new project is being created. As we can see, we have a blank page opened on the screen. And then we also have in our toolbox on the left all of the available commands to be able to build our user interface. We won't go through all of those options or controls, of course, because we don't have time, but also because that webinar is more about seeing how to hook up PowerMill to this Visual Studio application. But I will still show you that if you were to create a button, for example, you could grab one in here and then draw it the shape that you would like it to be. And then once you're happy with it, you will get all of its properties on the right side and pretty much everything, every actions or every parameters that you can set to it. Right now the name is button, so I could change it to create if I wanted to. As we can see, it's changing it on the screen. If I want to add an action to this button, so I would like to make sure that when I click on it, it does something and then closes the window that we have created. All we have to do is to go to that little lightning icon in here, and then we will have access to all of the different event handlers available. And of course, we can use the click one. Double click on it. It will create a bunch of code to do what we want to do. And then I could say end in here. That will end the process once the user click on the button. So that sub is only going to be launched when the user click on that button. Now we could run a test by hitting the start button at the top. And we should see the window to be closed once we hit the create button, and of course it does work. Now let's close that project and open another one that I've pre-created. Like I was saying, I'm not going to go through everything about creating an interface, so I've already pre-created that really simple interface with a scroll bar, and if I hit the start button, all it really does is to change a value in this field. So depending on where the scroll bar is, it will update the value in here, and I could type in a value if I wanted to. If the scale that I have on my scroll bar is not fine enough, I could decide to change it for, let's say, 0.2, hit enter, and then the arrow is going to be set to 0.2. What I want to do with that little application is to link it to PowerMill. If I open PowerMill, I would like it to modify the tool radius shading that is applied on the part. Right now we can see it's not doing anything except moving this number. Let's exit that, get back in here, and now it's going to be time to take a look at how we can hook up this application to PowerMill. The first thing that you need to know is that there are quite a lot of documentation available on the API forum. If I open it here, at this address, you will be able to find the Getting Started guide with PowerShape and PowerMill API. And then also in the specific link, you will see where to get the API from. The API is now an open source API, which means that every users can add to it. And once they do, they can update the Nugget library that will be available to everyone. As we can see, this version has been updated a couple of days ago. So if you were to add new parameters into it, it will be available to everyone. What we are interested in is going to be that comment, that package manager line in here. So I'll copy it already. And I will go back to Visual Studio, because we need to download that API. It's not coming directly with the PowerMill installation, simply because it's an open source API, which means that it's evolving every day. So we need to make sure that we use the latest one available all the time. To download the latest one, there are a couple of ways we can do. Usually we would right click on Reference, go to Manage Nugget Packages, and then we could browse for anything that is from Autodesk. And usually we should see PowerMill interface in here. I don't see it on my computer, so I'll go a different way. I'll close this guy, and then we can go to Tools, Nugget Package Manager, and Package Manager Console. And this is where we will be able to paste the comment that we've just copied from internet. And then I can simply hit enter, and everything is going to be downloaded and installed for me, so that if I was to go back to my Nugget packages and go to install, now I can see Autodesk product interface.powermill, which means that the PowerMill API is now available. And if I hit the little arrow in here, I'll see Autodesk Geometry, Product Interface, and Product Interface PowerMill, which is pretty much all I need to run PowerMill within Visual Studio. Let's close this guy. And now we will go back to where we can write some code. So I'll go back to my application and to the VB code of it. Now I can see everything that has been written in the background. I can see pretty much the same button click function that we did before in the previous application. But what I'm interested in is to link that to PowerMill. Now that we have integrated the PowerMill API, we need to import it into our project. So we'll write imports autodesk.productinterface.powermill. That will import everything we need from the PowerMill interface. And then we can create a new variable just underneath the class main window that will be called PowerMill. The way we define a variable in Visual Basic is a bit different than what we've seen in PowerMill. We need to start with dim to define a variable and then set the name of our parameter, and I'll say as new PM automation, open the parenthesis, Autodesk dot product interface dot instance reuse dot use existing instance. Of course, you may have seen, but every time I hit the dot key on my keyboard, it's giving me everything, so every possibility that we have within that parameter, which is really handy because we cannot remember everything, of course. Now that we have that PowerMill variable defined, we should be able to get into our appropriate sub and start writing some code. When I now write PowerMill, it's going to give me pretty much the same as the other parameters, which means that if I hit the dot on my keyboard, it will give me access to the list of available functions. Now, I don't see the one that I need for the special shading that I'm looking for, but that's not really an issue because if it's not part of the library, you can either create it yourself and make it part of the Nugget library for other people to use, or you can also use the execute ex function that will allow you to execute a command exactly as we are doing into a PowerMill macro command. I've already pre-recorded a macro that changed the shading to be using the minimum radius shading with a specific value. So let me bring this macro in just here. All I need is to get the shading type, which is this line, paste the command, and then I'll do exactly the same for where we change the minimum radius from the options. Perfect. Now I'll need to make sure my command is set correctly. It should be something a bit more like that. Perfect. And that 3.8 value is not going to be 3.8, of course. It will be the value that we get from the slider. And that's why I've created a sub that will change depending on if you're moving the slider or if you're entering a value pressing enter or even entering a value and clicking somewhere else on the screen. Now it's the same sub that will be used everywhere. That's why we can see that I'm calling it pretty much everywhere. And I'll make sure that this fixed value is now my diameter divided by 2 because PowerMill uses radius, not diameters. Now let's try to run our application and see if it does something to PowerMill. First, we can see that the shading is already on, and then if I was to move my slider bar, I'll see my shading being updated. And of course, if I was to change a value in here, hit enter, I'll get pretty much the same result also with some little radius in red at the bottom. If I wanted to change the scale, it's not a really big issue because we can always come back. And the way it's been set up, all we need to do is to change the maximum of it. Let's change it for 1.5. And the original value is going to be 3/4. And then of course we'll need to change our text to be 3/4 and maybe 1.5 up here. And also make sure that we position it right in front of it. And that's all we have to do. If I was to hit start again, look at PowerMill. Now I have my new scale that will allow me to go up to 1.5 inch. So that gives an idea how we can hook up PowerMill using macro commands. But now, one last detail. What if I would like to get a list of every tools that I have in my project? To get a list like that, we don't have to use the PowerMill.execute function. We can use what is kind of already available within the existing API. I'll do it in my exit button. The way we do is to define a new variable which is going to be linked to that session only. So linked to the current PowerMill session. And to do it, I'll create it just underneath at the top. Again, session as PM project equals PowerMill dot active project. Now I know that session is gonna include pretty much everything that we have in the current project. Now I can define a new tool variable. Let's see, define tool as PM tool. And I'll create a loop, pretty much like we did in PowerMill macros, for each tool in session.tools. I would like to get a message box that gives me the tool name. Something like that. So now once I hit the exit button, I will get that message box that gives me a list of every tools. Let's try exit, and now I see my tools being popped up. So that was a different way of getting information from PowerMill, and that is pretty much the way we need to work normally. But if we don't have access yet to the function that you're looking for within the current API, you can use the old execute commands that is available. And finally, the reason why we see that those lines are underlined in green is only because we do have a warning. It's not an error, it's a warning that tells me that this execute function should not be used and the function should be integrated into the custom software core instead. But for now, it was only for a test, so it's all good, and it would work even if you were to write your entire application with those comments. That's what concludes this PowerMill automation webinar. Thanks for watching, and if you have any question, feel free to contact us.